What is a smaller angle between the hands of a clock at 5:55? So to work it out, what I do is I draw the minute hand when it's at 12 or 0 minutes from where it will have moved to 11 in 55 minutes. So I'm going to work out this angle. Now that would be for the minute hand. We know that in 60 minutes it does 360 degrees. So in 60 minutes or 1 hour, we'll have done the entire 360 degrees. So in 1 minute, it will have done 360 divided by 60, that is 30, not 30, that is 6 degrees. That's 6 degrees. So therefore, when it is 55 minutes, it will have done 6 times 55, and that is 33, so 330 degrees. So what I now know is that this angle is 330 degrees. So my next challenge is to work out the movement of the hour hand. So we know now I will separate it into two parts, the hour hand calculation. So the hour hand first moves from 12 to 5. So this is 5, and this angle I would work that out first. Now for the hour hand, so that I know that in 1 hour it would move only 30 degrees. This is 30 degrees, 360 divided by 12. That is 30. One hand in 60 minutes, the hour hand, sorry, in 60 minutes it would move that is 360 divided by 12, that's 30 degree. So we're not interested in the 1 minute bit now, so we can do like 1 minute it would move how much. 1 minute it would move 30 out of 60, that is half a degree, half a degree, or 0.5 degrees. I can write 0.5 degrees. So that's the thing. So but the thing is, in 60 minutes it moves 30 degrees. So this period, this is 30 degrees. I mean, it is 30 degrees, isn't it? So 30 times 1, 2, 3, 4, 5. So this angle will be 30 times 5, that is 150 degrees. So we know up to when it moved from 12 to, this is 12 by the way, when it moved from 12 to 5, it has covered 150 degrees, right? So what we do need to find now is this bit of how much it will have moved from 5 to not really 6, the part before 6, because 6 o'clock, when it is 6, it will be exactly at 6. Now it is not exactly at 6, it is a little bit left, and it is this little bit of a movement, that, or this degree, that is what we have to find out. So to find that, we use what I did is, if I can think, like when the hour hand moves 360 degrees, the minute hand moves only 30 degrees. So if I say hour hand and then the minute hand, so if the hour hand has moved 360 degrees, the minute hand would only have moved 30 degrees. So if the hour hand has now moved, or it can move, so in this little angle is what the hour hand will move in 30 degrees, because this is 30 degrees. So if the hour hand moves 30 degrees, then the minute hand will have moved 30 out of 360 multiplied by 30. And that gives me, if I do some 5 times or 6 times 5 is 30, 60, and then 5 times 12 is 60, and then 6 times 2 is 12, 6 times 5 is 30, so 5 out of 2. So I get about 5 divided by 2 is 2.5 degrees. So what this tells me is, in the 30-degree movement of our hand, the minute hand moves 2.5 degrees. So this degrees, this bit is from 5:55 to 6, the minute hand. So if I make it clear that from 5:55 to 6, minute hand will move 2.5 degree. So that's the bit that's important here for this question. I think the most important bit, that it will move 2.5 degrees. So if that moves 2.5 degrees, then what is this angle? So this angle will be 30 minus 2.5. So this angle will be 30 minus 2.5, and that is 27.5 degree. And therefore the smaller angle, so therefore the smaller angle, will be, we have to subtract 330 degrees, not 333, 330 degrees minus 150 plus 27.5 degrees, and that is 330 degrees minus 177.5 degrees, and that gives us 152.5 degrees, and that is the correct answer. So the answer is 152.5 degrees, and that's the smaller angle. So this angle, this angle is 152.5 degrees. So if I erase all of it, to make it very clear, then this angle is the angle that would be 152.5 degrees.